All right, hearing none. I'm looking through and testing my quick name reading here. I think I'm wondering, Jeff, would you be game to start us off and talk about the work you've been doing mapping at Barry Arm?
Sure, Hig. Let me see if I can. Are you ready for that right now, or you want to say a few more things? Or are you good?
Let's just go for it.
All right, let me try sharing my screen. I think you're going to have to give me permission.
I just did. Now you should be able to.
Are you seeing anything yet?
Yep, that's working.
All right, let me start the slideshow here. Okay. Well, a few weeks ago, Hig contacted some of us at the USGS and asked us to just give an update on where we are at kind of overall, and then a little bit of nitty-gritty detail at Barry Arm in particular. And I think I tend toward the little bit of nitty-gritty detail more than the bigger picture. I think Dennis is going to do the bigger picture, longer term kind of goals that the USGS has for Prince William Sound and Barry Arm overall. But I'm going to start with some recent work. Everybody hearing me okay?
Yeah, you sound great. Actually, now I'm not hearing you.
By kinematic elements, I just mean different parts of the slide, the landslides that have moved independently from one another, either kind of cumulatively over the long term since the slides have since inception, or more recently, landslide structures give away details about materials. They lend insight into materials, boundary geometries, a whole bunch of things that give us some insight into the landslide histories, how they're moving currently, a little bit about how they may move in the future. They give us some constraints for coming up with basal slip surfaces and volumes. So they're pretty, structure maps are very handy to have. And that's what I'm going to be talking about just for about six or 7 minutes today. So on the right-hand side here, you see the different kinematic elements that I've defined at Barry Arm. For most of you, you're probably familiar with seeing landslide A and landslide B or something like that. For the purposes of this talk, landslide A I've divided into elements that I call the prow, the core, and the tail. And landslide B is the wedge. And these are just descriptive terms, and I find it easier to talk about names like this rather than A, B, and 1 and 2, and that kind of nomenclature. So this is what I'm going to talk about. But before I dive in too far, I want to talk a little more broadly about what we've done so far at Barry Arm in general. There's the structural mapping, which I'll show you a little bit more detail about here in a few minutes. And that was done from 1/10 of a meter LiDAR data from DGGS. And then we also got new bathymetric data from NOAA last summer, and those were 4-meter data. And we've only done one structural map so far, but I envision this kind of going on into the future as data sets become available, because it tells us things about how the slides are evolving if we can track structures and changes in structures. We're also doing bi-monthly radar set data collection, and either looking at the amplitude or intensity data when there's snow cover in the fall and the spring, and then phase data for INSAR work in the summer and early fall when there's minimal snow cover. And that's mostly just to detect slow movement that you might expect to be able to see with INSAR data in particular. And then in the bigger picture of things, and Hig particularly requested this, how is this all fitting into modeling work that the USGS has just recently started? That work's being done with a package called DCLAW. It's part of a GeoClaw package that Randy Levesque and others have worked on for quite a long time. The way that's being used is they're taking our kinematic elements and volumes and using that as kind of initial conditions for a bunch of different scenarios in DCLAW. The folks involved are Katie Barnhart, Ryan Jones, and Dave George. All right, let's talk a little bit about structural mapping in particular, how I did this work and what the results are. This is the DGGS LiDAR data, and this is landslide A from the first photograph that I showed. And the first thing, at least that I notice about this landslide, is that there are a couple different pieces here that strike me as being independent pieces, at least over the long run, independent pieces. So if we look right here, can everyone see my mouse?
Yeah, that's coming through pretty good.
Below landslide A, there's a big kind of block with an area at the top that looks like it's been extended quite a bit, a lot of talus cover. Above the word landslide A, there's another block. I'll call it a block. Of course, it's not a block. It's all broken up. And then there's a small area at the top here that looks like it's mostly failed, and probably a lot of it's already been transported away by the glacier. And then there's another kind of block over here. And when you start looking at structures, these pieces, at least in my opinion, they're reflective in the structural in structures too. This is the structural map. The yellow lines here are just normal fault scarps. The white lines with arrows are strike slip faults, and these are landslide structures. These are not tectonic structures. And then down here near the base of the slide in the bathymetric data, there are a couple little thrust faults. And this was pretty surprising to me. Oops, let me see if I can go back. This was pretty surprising to me that we didn't see more thrust faults. Thrust faults are indicative of compression. You normally see them at landslide toes, but they're hard to see in landslides where you have a glacier at the base or a recently receded glacier at the base. And the black line that I show here down near the toe of the overall landslide, that's just the base of a steep, my interpretation of it anyway, it's just the base of a steep raveling fjord wall. I didn't see any indication that there was compression associated with that black line. Higher resolution bathymetry data may provide some different results or different observations on that. I also mapped drainage paths. These are just channels that I visually identified. And then there are also debris flow deposits in the light pink. And I was just curious how these drainages might line up or not line up with structures. And it wasn't that useful. About the only thing I noticed was that some of the strike slip faults had drainages generally aligned with them. I would really like to get out in the field and start looking at some of these structures in detail to confirm that they are or are not what I think they are. Hopefully this summer we'll be able to do that. This just overlays the different kinematic elements, which were subdivided mainly based on overall kind of observations of the blocks, and then also divided up based on strike slip faults. So differential movement between the blocks is what I used to highlight these different kinematic elements. From south to north, the elements are the kite, the prow, the core, and the tail. And then lastly, some of our work from INSAR last summer overlaying on these kinematic elements, and this was pretty insightful to me anyway, that the kinematic elements are really reflective of the long-term cumulative motions of the different pieces, and they may or may not be reflective of what's going on today. But what we do see here, this is an interferogram, a wrapped interferogram from last September through October 17th, 23rd of September through October 17th. That's when we saw most of the movement last fall. And so each fringe here is about 3 centimeters of movement. And this is work by Lauren Schaefer in our group here in Golden. And so most of the movement that she was able to detect was in the core, a little bit lapping into the prow here in blue, but a lot of it was around the core and a little bit in the tail where there was a block still left in the tail. I don't have the structures overlain on this because it gets pretty messy, but some of these align nicely with structures, and other pieces like this central area between the prow and the core, they don't align that well with structures. So I think the kinematic elements are evolving, and we'll keep doing new maps to kind of keep track of how they're evolving. So this is the last slide. This is just a general kind of overview of what we've learned so far. I think I would make the case that these landslide A can be subdivided into kinematic elements, and these boundaries will evolve as deformation continues. No great structures indicative of large-scale compression at the toe, and I think this fits with the Dye et al. Paper in that the lower third of the slide is probably bulging upward, and then the front of that bulge is progressively raveling into the fjord, rather than a nice compressional toe. That's the deformation that I think is happening now. And this situation could also change once the glacier has gone from the toe completely. Widespread displacement detected in INSAR is mostly occurring in and around the core of landslide A. And then DGGS did some nice work last summer comparing LiDAR data sets, summer and fall, comparing LiDAR data sets from June and October. And that caught some great movement of the kite, the kinematic element called the kite. And then they detected a large, rapidly moving rock avalanche at the head of the core. And then in terms of how this fits into the DCLAW modeling that's ongoing, this is both a landslide model integrated with a tsunami model. So it's going to be both. In the case of an earthquake would be everything would fail at once. That will probably be their worst case scenario. And preliminary results from this will probably be in a USGS open file, and they're expected by the end of May of, a couple months away. And so I'll stop there, and Hig, if we have time for questions, I'd be happy to take some.
Yeah, sure. If anyone wants to jump in with a question, feel free. One thing I was wondering if anything, Jeff, in your experience, do you have any speculation as to how smaller failures, either some partial failure of one of the masses that you've identified, or of the head wall, I wonder if there's anything you see in what you're looking at that would inform whether we should be, what the probability is of a partial failure versus a complete failure. I don't know if you have any further thoughts on that from where we were.
Yeah, I do have a few thoughts, and I think you might think similar, actually, based on what we saw last summer with the kite moving. I think we'd have to ask Gabe for the actual amounts, but probably several meters at least. Right offhand, that would be the one that would worry me the most right now in terms of having the highest probability. I probably wouldn't assign a number to it, but it would be the top of my list in terms of a worry. After that, based on what we saw, the core area is active, and that's where the glacier is currently thinning and receding from the base of the core. So that would be a worry too in the near future. And I know what you're thinking, Hig, and that is if part of it goes, will the whole thing go? And in the case of the kite, I'd probably say no, not likely. In the case of the core, maybe. I think maybe one of the scenarios that Katie and others have high on their list is a failure of the prow and the core together, as well as the kite all by itself. I mean, those would be the two probably most likely things, at least in my opinion, that could happen. Or it could sit there another 50 years and slowly creep down the hill.
Thanks, Jeff. Any other quick questions?
This is Brian. I have a quick question. You mentioned earlier, I think maybe it was labeled on a graphic about the length of time before the glacier recedes completely beyond the landslide zone. How long do you think that's going to be?
I'm probably not the best person to answer this. Hig or Anna probably are, but right now the glacier isn't below the kite or the prow; it's below the core. And Hig, you've been tracking this more than me. I can say from 2010 to 2017, it receded completely from below the kite and the prow. And so given that, within the next 10 years, I'd expect it to be gone from the core. But I'm interested in other opinions on that.
Yeah, I could throw it on to someone like Michelle, but I'll just say briefly, like, I mean, it does seem to have retreated to a point where there's some stability there. I mean, there's that bedrock rib that's coming out on the south side, and I noticed in that, actually, that was some of the best view of that new bathymetry data I've seen. It looks like there's actually some sort of a slope beneath the face on the north side. But the retreat history, I don't really feel like I understand why Barry has gone through the process that we've seen, which has been really remarkable stability up till the early 2000s. And that includes as far as thickness. I would have, if you'd just shown me a series of fronts, I would have said, well, I bet it's thinning at the same time, because that's kind of the story of many glaciers across Alaska. But it was really keeping its thickness as well. And then early 2000s, it began retreating quite quickly and thinning as well. And that thinning continues. So it's unclear to me, like, what is the mass balance story there? I don't know if Michelle or someone else wanted to throw in a speculation there.
Well, we don't have a good hold on what the mass balance is yet, because we don't quite know what I haven't really done the legwork of like focusing in on Barry, which we should, or I should, I guess. But part of the thinning that you're seeing is a dynamic thinning. That's a process of the stretching and the retreat. So it's hard to kind of, in some ways, looking from above, deconvolve these two processes. Like, is it a change in the actual mass balances driving these changes that we're seeing? Or, as a glacier pulls into and started to retreat and has entered the kind of slightly deeper, it's not terribly deeper water, but slightly deeper water, it's also kind of stretching itself towards the terminus. And so that's causing the thinning as well. But I agree, there is that slope on it's hard to tell from the bathymetry what is necessarily bedrock that's driving the bathymetry versus we're seeing parts of the unraveling of the fjord sides that are changing the dynamics along the edge. But yeah.
This is Gabe. I'll just pipe in really quickly too. This is a really complicated fjord, and Berry Glacier is actually, it appears to be simple. It's quite linear, and the accumulation area is, by all intents and purposes, fairly straightforward, but it has a lot of really high elevation accumulation and not a really great area. But there's a massive amount of precipitation that falls in those ridge areas. And so that's really contributing quite a bit, I think, to its overall stability. The other part of this is the bedrock outcrops that you can see in the bathymetry carries on a bit, and you can see that it's been pinned a few times. The island that's just at the terminus was a pinning point for a while, and it's currently pinned, and you can see this in the LiDAR data. It's currently pinned on bedrock outcrop there. So one thing that would really help, and we should really put a lot more focus on the glaciology part of this, but one thing that would really help is to get some of the, kind of bed topography information that would really help allow us to predict, what the processes might be that are going to be contributing to its retreat, whether it's going to be rapid or slower based on the amount of bedrock that's available to help stabilize the glacier. The other thing I want to bring back the conversation to is Jeff's results are so interesting. And I think one thing that's really going to complicate the story a bit is the bathymetry. And it's a pretty, variable bathymetry in that area. But in the case that something like the kite fell from its very high perched position, and that's a lot of energy there, even something like that could really affect the terminus of the glacier. The amount of surface raising of the water and the calving event that would actually be generated from that sort of an event could be enormous. And that alone could cause some instability at the terminus.
I think maybe Melissa was jumping in with a question earlier. Did you have a question, Melissa?
Yeah, just a quick question. Because we were talking a lot about like the glacier dynamics and also potential earthquakes, and I was just curious if you guys were looking at other factors that could be also contributing to the landslide movement, such as like precipitation or anything like that.
Yeah, I can take a stab at that one. We've talked a lot about that, and there's plans this summer to get some MET stations installed right at Barry Arm. And I think once those are in, we'll feel a little more confident about starting to look at meteorological data, for example, and track, a time series of meteorological data and landslide movement. Also, having about 3 years of landslide movement would be helpful too, to have any confidence in any kind of a correlation like that minimum. So I think it's a good question. I think there's plans to do it probably from a lot of people on this call. But so far, at least from the USGS side, we haven't started down that path yet.
Just to add a couple generalities. I mean, we did see this summer that the main mass didn't seem to move much through the summer, but then it did in October when it was raining a lot. And if you look at some of these other large failures that have happened historically in Alaska, even though they had a lot of factors coming in, including glacial retreat being very likely a major one, both Ton and Gruink failed in an October that was particularly rainy. So we have every reason, I think, that to believe that precipitation could be a significant factor in when a failure might happen, even if it's not the overall driver of instability in the first place.
Jeff and Gabe, are you planning on putting in any differential GPS this summer at all on the slide?
From the USGS side, I think the answer to that is no, Anna, but Dennis might be able to. He's been working on the proposal that is going into our program office, and he might might be able to add something to that.
Yeah, that might be a good transition, Dennis, if you wanted to, answer that question, but go ahead and introduce yourself and speak more broadly to kind of what you see going forward as far as the USGS efforts. That would be great.
Sure, thanks. There's many of you on the call that I've talked to at least by email, but several names that I haven't. So just to introduce myself, I am Dennis Staley. I'm a research scientist at the USGS Landslide Hazards Program, where I have been working on post-fire debris flows. My job when I first started at the USGS in 2007 was to advance our understanding of post-fire debris flow initiation and the conditions that trigger these debris flows, to advance our ability to do hazard assessments and provide early warning. So I was basically the USGS landslide point person for a prototype debris flow early warning system in Southern California, and conducting hazard assessments. And so those two skills that I have in my toolbox, I think are going to be beneficial for the Alaska project. It's a similar type of thing. We started off knowing very little about post-fire debris flows in a relative sense in 2007, but we were able to take a prototype system and expand that throughout the Western United States. So I think a lot of the experiences I have through that work will be valuable moving forward here. So in early February, I became a part of this project sort of informally, and have been working with Tina Neal to manage the project in terms of getting all the USGS internal bureaucracy in order, so that once we receive our funding, we can hit the ground running this summer for field work. So the idea is I'm learning a lot from Tina as she served as the acting project chief. And then as she transitions back to her day job at the Volcano Science Center, I will kind of take over her role as she makes that transition back. So over the past 2 months, what I've really been doing is working to get our internal proposals together and our internal work plans and budgets together. So that, hopefully in a week or two, we will have an official project and be ready for field work this summer. The USGS project as a whole was authorized by Congress back in January of 2021. In the specific language is to address concerns that the potential for a major landslide and subsequent tsunami exists in Prince William Sound, Alaska, and to conduct data collection and analysis to develop a site-specific landslide hazard assessment and recommendations to support a long-term monitoring strategy. So Congress has authorized us to look not only at the Barry Arm landslide, but also other landslides in Prince William Sound, which I think is a pretty important component of our project that I don't want to forget about, is the broader regional context of the work we want to do. So the idea right now is to use the Barry Arm landslide during this summer, assuming we can do field work with the COVID situation, to basically learn what it is we need to know in Prince William Sound. So to do the site characterization, do some prototype surveillance work, and think about hazard assessment and working with the National Tsunami Warning Center for early warning, using the Barry Arm landslide as an example this summer, and then expanding that work more broadly next summer. So specific to field work this year, Jeff mentioned this in his talk, we will be installing, working with DGGS to install 2 MET stations, one on the arete above the slide, one on the opposite side of the fjord. And then DGGS will be installing 6 sort of smaller MET stations, 4 within the slide itself, and then 2 on the opposite side of the fjord. Part of the purpose of the MET station, it's not only to characterize the meteorological conditions and longer term climatic conditions, but also to calibrate a ground-based radar that we will be installing hopefully for a period of about 3 months. So the intention is to get that out late June, early July, should the purchase go through, and let that cook over the slide up until as late as we can in the fall. And the intention there is to get a better sense temporally of the kinematics of the landslide. So basically a higher resolution, both in time and space image of what's happening in terms of slide motion, like what Jeff's doing with Jeff and Lauren are doing with the satellite-based INSAR data. So MET station installations, radar installations, and then also hopefully getting onto the slide itself to be able to start characterizing the geotechnical properties of the landslide. Taking samples if we can for laboratory analysis, rock mass strength, shear strength, those types of things. To basically learn as much as we can in a very short time in an environment that's pretty difficult to move around in about the geotechnical properties of the slide so that we can make better determinations of the likelihood of catastrophic failure versus partial failure versus just slow deformation over time. So I think that, and then finally, there's a hazard assessment and early warning component of the project. And so some of the early work that's being done right now is using DCLAW to better inform the tsunami modeling. So basically trying to characterize the actual landslide as it goes into the water a little bit better to get a better sense of what the waves might be like in other parts of Prince William Sound. That work has progressed pretty rapidly, and we're hoping potentially to have a draft out into reviewers' hands fairly soon in the next couple of weeks. So that basically summarizes sort of our immediate plans for the summer. And then going into future years, we'll be working with folks on this call, the DGGS team, to compile an inventory of landslides we're concerned about in Prince William Sound, to do some similar types of field work, installing MET stations, installing the radar potentially in different locations for other slides of concern, to assist in the overall hazard assessment for tsunamigenic landslide hazards in Prince William Sound. So that's about all I have. Sorry for not having a more formal presentation, but I'm happy to answer any questions that people may have, at least as best as I can. You know, a lot of this still is in the preliminary stages of planning.
Thanks, Dennis. And you know, I was thinking maybe before we go to questions there, I don't know if Tina had anything she wanted to add, because you guys are working so closely together there. And I'm sorry, Tina, for not communicating more with you about what you might contribute here today previously, but feel free to go wherever you want with that.
Okay, yeah, thanks. No problem. Appreciate everybody's patience as this has taken us time to kind of get our vision together. But as Dennis said, hopefully COVID protocols will allow for some really great field work this summer by the consortium. I think the only things I'll add are that over the winter, partly just as a bit of a stopgap before Tsunami Warning Center gets their sensors in the field soon, we AVO put out an infrasound array in the town of Whittier, and this was an attempt to see if we could actually listen for any kind of activity in the Berry Arm and potentially detect increasing chatter if the slides were becoming more active. It's not really, was never meant as an early warning system, but just as something to potentially give us some insight. And that is still operating. We were collecting data. We've not seen anything significant other than a lot of noise, anthropogenic noise in Whittier. But I should say, early after it went in, I think there was some sense that we could see potentially some avalanching and rockfall activity in the Berry Arm. Anyway, that network is in place and will stay in place for the time being until we determine that it's really no longer serving a useful either surveillance or research purpose. The other thing that, of course, of interest to this group is that USGS, as part of the interagency group and broader consortium will stay very involved in engagement with stakeholders. We want to bring our work to the table when talking with communities. And as part of that, I think there's a meeting in early June in Valdez with Prince William Sound communities about resiliency in the face of coastal hazards. And Dennis, we hope, will be participating in that along with Tsunami Warning Center and DGGS to talk about the state of knowledge regarding Barry Arm. So I think that's all I have to add.
Thanks, Tina. I think that's pretty great. You guys got that infrasound up and running. You know, last summer there were 3 substantial landslides on Upper Barry Glacier, you know, well away from the water, but each on the order of 1 million cubic meters. And I imagine those would have showed up if they hadn't happened before deployment. So, you know, we may have something to listen to if that's going to be the norm now. Are there any questions for Dennis and Tina?
Dennis, you didn't really answer Anna's question about GPS on the slide. And I wonder if you want to comment on that.
Yeah,
put you on the hot spot.
Yeah, thanks for the reminder. Yeah, I don't think we have any plans, at least this field season, to install GPS on the slide. We have some background discussions going as to what would be done next summer, and I think that's potentially in the it's on the table as a potential instrumentation need. But I'm not sure we will do that. I think for this summer, we plan on characterizing the kinematics largely with the radar itself.
Yeah, and with that question, I guess I mostly was trying to get at what kind of warning system, even though it's under development, is in place or will be in place this summer when it comes to near real-time data. I know the Alaska Earthquake Center, they have seismometers out, and then the infrasound that Tina just told us about, because the satellite, and then you have the radar that you're going to set up. So I'm just curious about what kind of tools you currently have or will have this summer that can give a warning in case something big happens.
Sure. So I think the only official equipment that could be considered a part of the warning system that will be going out very soon is the water level sensors by the National Tsunami Warning Center. The infrasound, the seismic, all of those are still research grade in that we know that we can get a signal from those, but what that signal actually means in terms of activity on the landslide is still a bit of a question. And so the NTWC and their water level sensors will be sort of the binary whether or not a warning is issued, at least as far as I understand that. We're hoping that using the radar this year, we'll be able to determine more about what we see in the signal from the infrasound and the seismic, and that can better inform decisions at the warning center. But at this point, the water level sensors are the only things that are considered officially a part of the warning system for the summer. Tina, please correct me if I've gotten any of that wrong.
Yeah, that sounds great, Dennis. I think, Hig, this might be a good segue to summer to talk about Tsunami Warning Center. But one other thing to keep in mind about instrumentation in the region, the telemetry component of whatever goes out there is not insignificant in terms of it being a technical challenge, as we saw from this winter being rough on the Alaska Earthquake Center's seismic station health and camera health. So part of, I think, what will drive the ultimate network architecture out there is being able to figure out real-time telemetry in a way that supports a warning system. So I don't know. So is this a good time to move to Tsunami Warning Center plans?
I think there was one question. Aaron, did you have a question you wanted to jump in with there? I saw there was some good chat going on, but I can't read that and and listen. So I'm feel free to just jump in.
Oh, I was mostly just gonna say what I said on chat, introduce myself. My name is Erin, and thank you guys for inviting me to this meeting. I work with the tribes in the Chugach region, which includes the Prince William Sound area, on developing climate resilience plans. And so I just wanted to put it out there and offer any help that we can for communicating with our tribes. and also just throw out that idea about, we've been thinking about doing some sort of maybe local environmental observation network sort of design where we give hunters and fishers in the region GPSs or something, just to go kind of do some citizen science and document anecdotal instances of an instability that could lead to maybe research leads. So yeah, I just wanted to introduce myself and throw those ideas out there, and thank you guys for doing this work. And I'm very excited to learn more about the Potential Warning Center. I know that's something our tribes, especially when news about Barry Arm first came out, we got a lot of concerned phone calls about that.
Thanks, Aaron. I really appreciate you being here, and yeah, thanks for contributing there. And we want to find, I'll speak for myself. We want to find good ways to communicate what we're learning, and I see these meetings as sort of one of the more organic ways that can happen. It's sort of not very many rules here. Anyone who wants to jump in with questions, provide anything from the most technical end to the broadest general public kind of questions are all fair game here. So go for it, Michelle.
I just wanted to add, Aaron, it's great to have you here, and it's great to have Caleb and Kate and Dave and other people who are working on the kind of bridging communication with the communities. And I was just curious because, sometimes there's this whole like reliance on infrastructure, and you mentioned having GPSs and giving them to some of your observers and the people that you're working with. And I've done a little bit of work with communities up on the North Slope, coastal Alaska, Shishmaref, that area there. And I was just kind of wondering how do people typically communicate in this area, and how can we use those ways that those tools that they already have? So if they have smartphones, like sometimes it's easier to just share, ways that you can collect GPS on your smartphone and you can take a picture, right? And so, thinking about how we could use this group to kind of figure out how do we create a portal through which people could actually add in their photos, add in their GPS into a database, so that communication is two ways and easy to access. So that's just my few thoughts on that.
Yeah, no, that's a great idea. And I definitely think like some sort of cell phone thing would work in some of our communities. But then we have, I think a lot of the fishing and hunting activities tend to happen in pretty remote areas that don't have cell phone coverage. So maybe we could identify, maybe that's something my organization could do actually is, identify a couple of really active, really far traveling individuals in each community and ask them if they'd be willing to, give them a GPS and ask them if they'd be willing to do that separately from a cell phone. So I could see there being maybe a couple different levels of effort there. But yeah, thank you. That's great. And I appreciate all the comments that everybody's giving back. I will reach out to all of you.
I'll just say one thing here, and Aaron, thanks for bringing this up. This is really great. We have a small amount of funding to develop capacity in our existing app that we own through another project. It's Community Snow Observations, which is based on snow, but the app is Mountain Hub. And we have a small amount of funding to develop a landslide hazards tool set associated with that. And our plan is to build out this landslide hazards tool set within that app and get some comments on the best observations to incorporate on that. And I'll solicit the community here for that. And then photos can be taken, and those photos are geolocated. And then when the phone is back connected to Wi-Fi or the cellular network, it automatically uploads the data. And then those data points too, if you're in a boat, for instance, those can be edited on a PC or a Mac and put in kind of the spot where it should be instead of, in the middle of the water body. And so that could then be used in all places around the world, but specifically related to this work. And what we can do, I guess, and this would probably require just a little bit more funding directed at it, is develop that so that it can be accessed by everyone and publicly available, so that people can utilize that and perhaps even push into the USGS National Landslide Hazard Database.
I think there's a lot of really cool potential here, and I've been talking to folks down in Juneau also about some of locals who would be interested to potentially contribute through such a system. So I really love to see that move forward. And that might be a great topic for our whole next meeting, is to talk about, sort of how we could develop some of these citizen science approaches to especially to ongoing kind of monitoring of areas that are of concern. I also want to say we got about 11 minutes left. I do want to try to reserve 5 minutes at least at the end to show a little bit about Columbia Glacier, because I think it really connects to what we were talking about, and especially Dennis's note about interest in Prince William Sound more broadly. However, we also have Ben and we have Summer, who both maybe have things to say. And so I wonder if Summer, do you have just a just a super short update from the tsunami warning centers and or Dave that you could provide?
Yeah, I can briefly provide an update. We're on track to deploy our tsunami gauges, those water level sensors that were referred to earlier, later this month, and we'll have 3 sites going in. It will take us some time once we get those in to make sure the data is flowing as intended and test our alarming and do some other things behind the scenes. So we won't be able to warn immediately upon the sensors getting in, but it's certainly a big step for us. And we're eagerly looking forward to more information from USGS about their modeling efforts. We're hoping to collaborate more with AEC. We know they've been looking at the earthquake signals and the seismic signals coming from their stations. So we're hoping to get a better idea of what baseline activity looks like, so we can recognize when something abnormal is happening or things look to be accelerating. So just a reminder that we don't have any congressional funding for this effort, despite a congressional mandate. So we're hoping to use our partners efficiently and really work with every other group here.
Thanks, Summer. And Ben, did you want to add a bit about the landslide inventory database effort, and kind of, especially this might be an opportunity to say what other people could contribute to that effort, or whatever you think would be most useful?
Yeah, thanks, Hig. Hi, everyone. Ben Miras with the USGS. We have been, the last few years just trying to compile any geodatabase, published geodatabase of landslide occurrence across the US. I'll put the link in the chat. And, if you open it, you'll see that it's pretty sparse for Alaska. And so our hope is that through the coming years, any and all published gray literature or otherwise landslide inventories, we'd like to link them through the site. It's really meant as an information portal and a place to kind of put all available landslide inventories together in one place. It can be accessed. And if you look at the lower 48, there's kind of an issue of data integration and some things we're looking at there. If you look at Alaska, it's pretty empty. So we're just trying to get any information into that. And in part, there's kind of some broader mandates that are going to be likely part of the National Landslide Preparedness Act, that we want to just have all that information together in one place and accessible in one place. And so that's our main goal, is to highlight all the different landslide inventory data that exist across the country. And so if you have anything, there's a link where you can contribute through the website. You can also just email me directly, bbmiras@usgs.gov, and look forward to any and all information. Thanks.
Thanks, Ben. Are there any questions right now? Or just comments people want to jump in with? Okay, I'm gonna just take over for a moment here, and I just want to introduce this instability that caught my attention. And this has been one thing that's come out of my sort of unsystematic but statewide effort to just kind of find places that are of potential interest or potential concern. So a little context here, and we focused on this point here where my mouse is. This is Columbia Fjord here. So Valdez is over here. So you could, in a boat, you could go out from Valdez Harbor, go in across. This is the moraine at the mouth of Columbia Fjord where the glacier was not that long ago. And now it's retreated back, and it's actually retreated to about here. This image is a little out of date. And so there are a few areas of possible instability, but this one kind of came to the top of my list in this area, partly because it's pretty large. It's not as big as Barry, but it's similar in scale to like the mass that failed in 1958 in Lituya Bay and 2015 in Ton Fjord. So some tens of millions of cubic meters, most likely. And there's some evidence that it's actually moving right now. And so if we look at this weathered talus slope, you see this light colored line, that sort of thing. And it possibly is associated with this light colored scarp up here. That would be typical if there had been recent motion that was turning over lichen or weathered surfaces and changing their color. And there's another site like that up here where we see this wavy line cutting across, from this angle of repose slope onto a lower angle slope. It's the sort of thing I would expect to see if this was moving. However, this is just, you now know kind of everything I know about this site. We haven't done any radar interferometry or anything to actually determine if this is moving, but my suspicion is that it is moving. Now this site's interesting in part because it's large and active, but I'm going to go to the most recent photo we have here. So it's snow covered. It's not as good for that, but you can see that the ice face is fairly close. And this is a little bit out of date. There was actually a lot of retreat this winter. It was fairly stable over the last summer of 2020. And it's somewhere back in this area now. So if it failed today, the landslide would run onto the glacier. Might well be that some would reach the water. A landslide this size would be really mobile on top of the glacier. And so probably some would reach the water, and it might produce a tsunami that would be particularly concerning for anyone who's in really shallow water. But with this retreat, it may well be falling directly into the water if it waits a few years. And I went recently and just, I have to put this in, here we are. I sent around a version of this, I've updated slightly, but just took a bunch of satellite photos and looked at where the front was along a line kind of parallel to the margin of the glacier in recent time. And you can see there's some big variations, like there was a period of rapid retreat here in late 2015 through early 2016, then it sort of stabilized and it's retreated some since then. You can see the stability last summer where it really didn't change much, but then this winter it popped back significantly. If you kind of, draw a simple line over the long term, it's not too far from a constant rate of retreat of about 2 meters per day. My caption says per year, 2 meters per day. So if we just imagine that might be how it continues, then the ice would start retreating past the toe of this instability in late of 2022, late 2022, and continue for a few years there. And looking to places like Gruink, for instance, the landslide that happened there in 1967, although the glacier retreated fairly steadily past that slope, it was during the time it was actually, the ice face was under the slope that the failure happened. Very large tsunamigenic failure there. In Ton, it's a little bit more complicated. The glacier retreated back, and a few years after it passed under the toe of an instability there, that instability became very active, moved down some, but then it restabilized, sat there for a decade or so, then started moving for a couple years and then failed catastrophically. So it's not like there's a straightforward story that we know, these things are going to happen together, that the glacial retreat will be associated with failure. But in these large slopes, there does seem to be an association between the passage of the front under the instability and the failure of the glacier. We know also from work like the Coast et al. Paper on Great Altreich in the Swiss Alps that thinning is certainly an important part of this debuttressing story. You know, the Columbia Glacier was way up here just a few decades ago, and now it's pulled down. I think this is 300 meters or something like that. I forget the height change here, but it's quite significant. Maybe even more than that, actually. And so, you know, the forces on this mass have changed tremendously in that time period. But I think the evidence is pretty clear that the most dramatic change is when that front retreats past. And so what that might mean is that when we talk about hazards that for people traveling into this area, this year, they should probably be, you know, concerned, you know, think about it, especially if they're camping, have evacuation plans in place, that sort of thing. But if they waited 3 years, then maybe the concern would be an order of magnitude higher. So we have a really, really big, potentially a big change in the amount of hazard this presents. And I've been speaking with people who work in this area, who do tours and such out of Valdez, and this is a very active area. There can be several hundred people in this fjord at one time. So I think it's a serious concern as far as human hazard. And I also wanted to highlight it just from a scientific perspective, like some of the conversations I've had with Noah Finnegan about, you know, what exactly goes on when you debuttress a slope. We may have an opportunity here if we do get instrumentation in sooner rather than later to see the way a slope responds, the way Barry Arm responded a decade ago as it experiences kind of the peak of debuttressing as the front goes past. So I'll leave it at that. And I know we're on the hour, so if people have to go for it. I'll linger at least for a little while here, and would be happy to chat with anyone who can linger a little bit.
Okay, can I just make 2 comments? This is really cool, and I'm really glad that you saw that. So 2 things I was thinking of. One is the Extreme Ice Survey set up their instrumentation to look at the terminus of Columbia, yeah, right on that hill. And they have, and then Shad O'Neill continued that. And then when he left, there's others that have continued the time-lapse photos. So and they're pointing directly at the slope that you're looking at. So I'm wondering if we could get a hold of that in some way so we can look at the evolution of those features, because I think the resolution of the imagery and the angle of the camera might capture that. And I was also wondering about the development of the gully, the rill that is just northeast of that slope, and how that might, you know, what's the evolution of that piece and how that might, because that looks like it could be influencing the slope as well by kind of undercutting on the lateral side.
Yeah, I haven't, with the imagery I've looked at, I don't have any specific observations about this, but I think I agree it'd be good to look at. And I'd also say that, you know, in now having looked at quite a few slopes like this, the association between this kind of deep-seated instability and then shallower processes, it seems to be very common that, you know, that whether the deep-seated instability is activating shallow, you know, raveling and superficial erosion, or the reverse, that shallow erosion is, you know, removing support and leading to greater deep-seated instability. I think either one of those be on the table as possibilities. I did look a little bit at that imagery. I haven't like gotten the raw imagery or anything. It's hard to appreciate the scale of these distances, and I think it may not be resolved well enough, except for maybe that you could pick out some of like what you're talking about with like gully evolution and such on the face, because that's better resolved, but this upper surface is not so well resolved. And part of the, you know, another reason that this is scientifically an interesting site is there's been a tremendous amount of work including what Michelle's noting on Columbia Fjord. Apparently there's, NOAA is actually doing bathymetry surveys, maybe even this winter. I don't know exactly what the story is there, but I just heard from one of the locals that they were out doing new surveys in the area. So there's really a tremendous amount of data and history, kind of knowledge of this glacier out there, and that could really be a jump start on this site.
Could I say something briefly, Hig? I just one to follow up on the gully thing. Like my experience on big, slow landslides in California is that you recognize them often because of the gullying on the surface. So, and I don't think people understand why there is this, but there clearly something. And in fact, when I look at that, it looks like a slope instability from, yeah. So there's definitely something there. The question I had is, this experiment that you laid out, which seems like a really, really valuable thing to exploit. And I wonder if separately we might talk to NSF from a rapid perspective for exactly, the reasons stated. And so the question is how, like, I can imagine even without GPS, I'm really increasingly more fond of using extensometers because I've started to look more deeply into, you can actually see the details of how the slip works in a way that you can't see with GPS. And they're way cheaper. And so the question is, how hard would it be for us to like charter a helicopter to go here and just spend a day putting instruments here, like crossing a bunch of those cracks just to get something there?
Helicopter charter out of Valdez is, as far as getting a helicopter and everything, that's really active. There's a lot of heli skiing and everything there. So yeah, getting there I don't think would be. It might even be able to charter straight out of Anchorage. Angela, I don't know, she was on earlier. Now I can only see a few people because I'm in presentation mode. But the Forest Service permitting would be presumably a question there, and I know that we've got a lot of folks from the Forest Service who have been really engaged here, and I imagine that we could find a good way to go through that. It's not like this is a big like hiking destination. It's pretty hard to get to without a helicopter.
Well, I think there's a compelling case to go to NSF to say, like, it's from an early warning perspective, but also from a fundamental science question. And it seems like this is just a quick injection of capital, a week or two of field work, and it could be like a tremendously valuable thing.
Yeah, it's interesting. When I've interacted with Rapid, it was post-event kind of thing, in a different sort of a different narrative, but it might be with the the question is, would they just say, well, hey, you've got enough time actually to do a full proposal here, or would they say, yep, this is a rapid
well, so
case?
We can write a full proposal. That's fine. I mean, I think presumably, I don't know if Anna is still on the call. Presumably, we're going to hear one way or the other soon enough from NSF. And so, in the likely event that we're not funded, we'll pick up the pieces and start trying to figure out how to break it and balkanize the proposal, right? And like start working on chunks of it. And this would be an obvious thing to do. I think most of the pieces are already there, so it'd be a pretty easy proposal to write because we've sort of got the framework already established. And it's nice and contained, right? It has a lot of things going for it.
Yeah, one other piece on that end, I don't think this would be the right funding to do the sort of scientific study that we're talking about at this moment. But as far as getting some basic information, the Prince William Sound Regional Citizens Advisory Council, that's kind of responsible for watching the oil traffic and trying to understand what risks are associated with that. They are potentially going to put out an RFP that would be about instabilities in this area. This is a little bit of a stretch because with the moraine, it's unclear to me that this actually poses a risk to the oil traffic. However, the city of Valdez has been engaged in that conversation, and they are concerned about this, and I think they may actually be able to like supplement that funding a little bit. I don't know how all those pieces are going to come together, what it's going to look like, but that might be something that within a few months we hear about whether that RFP is coming out. And that would be, I think, on the order of $100,000 that could be used for instance, get actually out in the field and confirm that these funny little light lines and such are something real, or look at what's going on right now.
Is there LiDAR for this area?
That's a good question. There isn't in the DGGS server, but gee, there's been so much work done here. You'd think that someone had done LiDAR. I mean, it is a nice, treeless surface. So Arctic DM, for instance, will be pretty decent.
Right.
But I haven't actually reviewed the Arctic DM tiles for this area, so I don't know what there is.
That's really cool. Yeah, I didn't appreciate the scale until you sort of talked about the thinning of the glacier. It's really huge.
Yeah, it's a big one. I haven't, for instance, done the exercise of making a profile and cartooning, I like Anya's term, geofantasizing about what the failure surface might be. But, just kind of like throwing numbers out there, it might be 50 million cubic meters, something like that.
Okay.
Can I just add one more comment? Somebody was mentioning NOAA getting in and doing bathymetry. The problem has been for Columbia that the moraine at the 1980 position that you pointed out is really shallow. And so it's been tough to get big ships in there. But for instance, a group from the University of Washington went in there in, say, 2010, I guess, 2010, 2011, the first time that the ice blew out of that fjord. And so we have bathymetry, and it would be really great to get back in there and get repeat bathymetry up close to the terminus that it is today. So we could actually capture, and it's been an ongoing conversation with like Bernard Halle and others, to go back into Columbia and recapture the bathymetry so we can look at the changes that have been happening. And so a small boat would be the optimal way to get in there and get up to the terminus. And it would be very exciting to do so for multiple scientific reasons. But yeah, so just throwing that out there. If there's a possibility.
Yeah, one piece of that is just, I've looked a little bit at the surface topography of the glacier here, and to me it looks like it's deep through here. Like it's not, there's no like bedrock pin that's coming up. Maybe when it gets back to this corner, but this section here, the topography is really subdued. And from what I hear, that the depths out here, I forget, like several hundred meters. It's really deep. I mean, this is the other arm. This arm actually is pinning now. Like I think I spoke with a kayak guide that works in this area, and he was saying he thought pretty much 99% of this now is rising above the water, but that's not the case for the east arm. And I'd also note that there are some other smaller, instabilities like in this area. There's been, actually, this is a beauty here. There's been at least 3 significant alpine slides in recent years. This one is, I think, 2019, if I remember right. You can see this one over here. And that's one of the patterns that I'm really curious about. If we zoom out, so there's 3 here. There are 5 here of these alpine slides. We've got, other than that, there's like 1 here and 1 nearby there. And then there was 1 somewhere around here. But really not much else in all the Chugach here. So why is there this really tight clustering? And is there any association between the presence of these large deep-seated slope instabilities at Berry and here and the high alpine failures? Offhand, I don't see a reason why there should be an association between those two, other than maybe if the rapid retreat is a factor, then so rapid retreat might actually drive changes in microclimate in alpine settings, and that could be something. But anyway, it's a little tenuous, and I don't know what story is being told there, but there is sort of this large scale thing that I'm quite curious about.
Hig, one of the things that, and this is a parallel and separate conversation we've been having, but not unrelated, is the tectonic overprint of this whole landscape and where the big shear zones are and how that might relate to both rock damage and where the big trough glaciers are ending up, right? And so it might not be, there might be a pattern to the big slope failures and the big glaciers that are connected because of rock damage. That would be interesting. And you're in this giant sort of transpressional corner here that's really interesting. So.
Yeah, well, and they're giant glaciers that are also remarkably straight in some cases. Actually, the mapped faults in this area, as far as mapped potentially active or even Pleistocene faults, is really sparse. But my take on it, I don't know. I think we probably lost Peter by now. I know he had another commitment, but I'd love to hear his thoughts on this. But yeah, there's got to be active structures in there, but I think they're just really hard to pick out given the just tremendous glacial, scour and how broken up in general the rocks are. This is Barry again here. There's a big, scary looking instability above Whittier here that fortunately doesn't seem to be moving right now, or at least I can't see that it's moving. Then there's one that is actively moving here. And also, if you just say, let's just draw a line, there are a whole bunch of other smaller instabilities and stuff there. And then there are those 5 recent landslides up here. I wish I had another, it'd take me a minute to load this other GIS data to show that really well. But anyway, it's just kind of like, yeah, do we start drawing lines? Maybe that is
tempting. It's tempting to do that, but yeah, I agree. That's very like a fairly unconstrained exercise. But there's good physical reasons for this. Yeah.
Well, certainly if you go out, so this is Montague, and the whole outer coast of Montague has giant deep-seated instabilities that look pretty active, and that one ruptured, the fault underneath there ruptured in 1964 and led to over 10 meters of uplift or something. It's really incredible change there. So that's probably not a coincidence that there's that line of instabilities. Well, any last thoughts here before we log off? Well, thank you, everyone. I'm going to download the chat too, so that I can, I'll post this recording. And yeah, really appreciate everyone's time. And maybe next time we will talk about citizen science and landslides. I think that could be a really great one. And Noah, Michelle, let's keep the conversation going about Columbia. Anyone else who wants to join in, feel free to.
Yeah, I'll say I'm doing the USGS landslide hazard seminar in a couple of weeks, and I'm going to talk some of the stuff that we've just kind of discovered that from really high resolution instrumentation on landslides that I'm super excited about. So these might be very pertinent to thinking about the stability of these landslides and fjords. Even though the settings are a little different, the rocks are a little different, I think stepping back, I think some of the processes might be really similar. So it might help guide thinking about what to do in the future.
And I'll apologize and say, can you repeat the first part of that, Noah? Because my internet flaked out on me.
Yeah,
I'm the recorder, so you gotta tell me.
Just that I'm going to talk at the USGS landslide hazard seminar in a couple weeks on sort of slow slip and big landslides and how it might work.
Okay, great, excellent. Yeah, I'd be if before you do that you wanted to have a little tour of related things that I'm seeing up in Alaska, that could be fun.
I'm going to stay focused, very California centric for the talk, but yeah, well, that's not necessarily yet. Let's talk beforehand. Actually, that's a good idea. But I got to go have lunch now.
Yep. See you. Thanks, everyone.
Bye-bye.